time to learn how to juggle and review Newton's laws and projectile motion. Okay, probably the key thing is to review Newton's laws and projectile motion, but we'll learn how to juggle along the way. All right, so first of all, we got Newton's third law. Of course, that says for every force, there's an equal and opposite force. Okay, so I just have this ball sitting here. It's forcing down. My hand is forcing it back up, equal and opposite. And even if I let this drop, okay, it puts a force on the earth, and the earth forces it back up. Okay, of course, the earth is so massive that it doesn't appear to move, but of course, the ball does. Okay, so of course, with rockets and so forth, that's all Newton's third law. All right, so Newton's first law, okay, objects at rest stay at rest. Right here, just stay at rest. These balls are just sitting there. They're going to stay at rest until we put a force upon them. Okay, so now if I throw this up in the air, I put some force on it, according to Newton's first law, it should keep on going, right? Okay, let's see how it does. Well, it doesn't, right? You guys know it goes up, it stops, and comes back down. That's because there actually are a couple forces on it. One is just air resistance, which slows it down, but that's not much compared to gravity. Gravity, of course, is accelerating it down at 9.8 meters per second every second. So as I throw this up, it is slowing down by that rate. When it hits the top, it stops going up, and of course then it accelerates to the center of the earth at 9.8 meters per second every second. So after 1 second, we're at 9.8 meters per second. After 2, it'd be twice that on down the line. All right? So that's why it actually is obeying Newton's first law, but there's other force on it. All right? Newton's second law, of course, you guys remember, is the F equals ma, or maybe better stated is acceleration is equal to force divided by mass. Right? So if I take this object, I put a little bit of force on it, okay, it's going to go up a little bit of acceleration. If I put more force on it, of course, it's going to go much higher. Okay, okay, so objects will always accelerate in the direction of the applied force. Okay, and the greater the force, the greater the acceleration. The greater the mass, the less the acceleration. That makes sense. So for lighter objects, it's easier to get them to accelerate versus if this is a big old bowling ball, it'd be kind of hard to do. All right. So those are the three laws, and the other one is projectile motion. Anytime you throw an object, or anytime an object is launched and there's nothing propelling it at that time, it is a projectile, and projectiles always have that parabolic motion. Okay. So if I take this object and I throw it this way, it's going to curve down to the ground, and actually that you describe that its path as a parabola. Okay, of course air resistance, and then of course gravity is pulling it down. All right. So to juggle, what we're going to do, we're going to apply force to this ball. Okay, get it to its top. Okay, so throw it up there. Okay, when gravity slows it to a stop and comes back down. Okay, when it gets to its top up there, you're going to throw this one underneath. Right, so here we go. Okay, up, up. Just use two balls. You do this maybe 100 times if you really want to know how to juggle. Learn how. Just get that action going. Okay. Once you've mastered that, then you can add that third ball in. All right. So two balls, wherever hand you're starting, you get two balls in that hand, one hand in this one. All right. So here we go. Every time it gets to the apex, I'm going to throw the other one underneath. All right. All right. This is going to be a good one this time. There we go. All right. Okay, Newton's laws of motion and projectiles.